church discography. Wake up. Okay. I got that. Oh, there we go. Oh, Zapfan's here. Okay. Yeah, oh no, Fraser fell asleep. You know, it's 10 o'clock for me, and I am not a night person. And so, yeah, I could very well fall asleep midstream. And then I was telling my wife she'll notice, she'll be browsing Reddit, and she'll be like, oh, Fraser fell asleep. Mic volume really low. Sound volume really low? Let me see. Testing. No, the mic level's pretty good, from what I can tell. 5 p.m. for me, Paul Holt. This is for you, Paul. For you in Australia. Hey, everybody. Welcome to the Asian, Australian version of the question show. This is the version. It's Sunday night, 10 p.m. here in Canada. But if I did my math right, it is 5 p.m. Just time, ready to finish work on Monday night and have a beer in Australia. So, yeah, this is the second one that we've done, and it worked out really well. It was good because there's like a lot of people who'd never seen an episode live before. This for the Americans, people in North America, you can go to bed now. It's fine. You don't have to stay up for this. This is what we do to Zapfan and John Suffield. We make them stay up. So, right. So, hey everybody, how's it going? If you have no idea what it is that you have stumbled into, this is going to be a live episode of The Question Show where you pose your questions randomly to me. Yeah, Australia is like 4 time zones. Specifically, we're targeting this for Sydney, where most of them live. So go ahead, put any questions that you might have into the YouTube comments, and then Zapfan is here, and also his trusty computer sidekick will grab questions and put them into the database, where I will be able to look through them and answer them. Now, before we get started, just a few ground rules here. The first thing is just remember that I am a journalist, not a scientist. And so while I can sort of channel the shared knowledge of the scientific community, I cannot add any additional knowledge above that. So I have no opinions about various scientific matters. I cannot elaborate whether one theory or another is a better theory. I can just tell you sort of like what the ponderance, what is the scientific consensus. The second thing is I try to give emphasis to the people who have never had a question answered before, but since that's like a lot of you people here, that's the hope, is that none of you have had chances to have your questions answered. So hopefully we'll have a lot of fresh faces. And then third, which is we try to sort of keep an eye on what are the questions we've been answering a lot of, and so I try to sort of minimize the same question over and over again every single week. So if I skip your question, it's not that I didn't think it was a great question, just that maybe we've answered that question a lot recently. Okay. So let's get started. Go to this. Go live. I got 8 hours on the camera. Okay, that'll do. There you go, Chad. And just ask your question once. Don't ask your question a bunch of times. We got it. It's in the database. All right. So as usual, for those of you who don't know, I've got a bunch of questions that are prepared that came from the YouTube comments. And we'll go through those first, and then we'll get into, and that'll give you time to sort of think of the good question. All right, let's get into it. Coyote Casey. Hey, Fraser, question for you. Have we found any ore veins on the moon or Mars or other planets? Do these formations exist on them like they do on Earth? So, ore veins here on Earth are caused by various geologic processes. Oh, let me start my AC. Okay. Ore veins on Earth are created by various geological processes that seem to be unique to Earth. So a couple of examples are plate tectonics, that we seem to have this sort of floating continents, this crust on top of the mantle. It doesn't look like this is a thing that appears to be on other worlds. Like maybe Mars or Venus had plate tectonics in the past, but they don't seem to have them today. The second thing is to have hydrological processes. So you want to have things like lakes and rivers and vents of water and oceans and things like that that can allow various minerals to accumulate into concentrations. And while we do have we have lots of that here on Earth, there are only like past historical examples of that on other places like Mars. And then the third thing is that many minerals are created through biological activity. When you think about like the limestone cliffs, right? You've got this place where the bodies of animals built up over time into giant concentrations where people can mine that out for limestone and things like that. So there aren't direct analogies for what we have on Earth to what we can see across the solar system, but there are definitely concentrations of various metals and other really useful elements on other worlds. So let's talk about the moon first. So the moon is, covered in ancient hardened lava. That when you look at the moon, you can see these dark areas, these mare, and these are ancient flows that came out across the surface of the moon. And we know that a lot of that material is rich in elements like titanium and aluminum and iron. And so in many cases, in silicon, like you literally just have to dig up any chunk of the surface of the moon, especially certain places where you can actually see concentrations of titanium in the upper element. Places where you can see titanium in the flows and things like that, and you can sort of concentrate that material to if you need those kinds of metals. And then the other thing on the moon is that there are these weird formations that are called creep. And that stands for potassium, that's the K, and then rare earth elements, and then phosphorus for the P. And it's believed that these are the places where the magma ocean, when the moon was covered in a magma ocean, these were the final places where the magma existed before it finally solidified. And so if we go to those locations, those creeps, we can try to access those concentrations of those elements. And so those will probably be places where future mining operations on the moon will go. On Mars, we do know that there was the activity of water for long periods of time on the surface of Mars. And so you're going to have hydrothermal vents, which have probably concentrated material. You're going to have ancient lake beds, places where, minerals came out of the water and formed a sediment at the bottom of some ancient lake that you could then harvest up. And so there are going to be places like that. There are also ancient lava flows on the surface of Mars that theoretically you can go and find various concentrations. And in fact, some really great surveys have been done from space by various spacecraft orbiting around Mars. And so there are actually these great mineral maps. And so one of the places, when NASA was choosing the location for, say, Perseverance and Curiosity, they were thinking about what are the kinds of minerals that we may find. And there was a really interesting sort of discovery that was made by, was it Curiosity or Perseverance? Oh no. There was a really interesting discovery made by one of the rovers recently where it was rolling along and it crunched over a rock, and it turned out that that rock was made of almost pure sulfur. And we see these kinds of formations here on Earth, and it was not expected that you would see these on Mars. And these were probably some ancient hydrothermal vent. And so, sulfur is going to be incredibly useful on the surface of Mars to future explorers, colonists, whatever. And so to see that is to tell you, yeah, you've got a vein of sulfur that is coming from deeper down in Mars. And so that's a place that you could actually go and mine to get those. So yeah, in general, there are concentrations of various minerals on Mars and the moon, which people will be able to go and find and harvest. Oops, okay. Alexander Glimt 3945. How do you measure temperature in space on the moon where there is no molecules in space that get warm or cold? Does it not depend on what surface you are measuring on? For example, black, white, or reflective surface. What is stated that it can be 120 degrees Celsius on the moon? What is it that has this temperature? Right. So whenever you say that the temperature of space is whatever, 2.7 Kelvin, or 120 degrees Celsius, or 2.5 million Celsius, then you'll have people going, whoa, 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 wait a minute. You can't say that space has a temperature because the temperature is caused by molecules. And the molecules are the ones that are actually giving off the temperature. Space itself, the vacuum of space, has no temperature. And that is technically correct. So if somebody says, well, what is the temperature on the moon? They're not talking about the vacuum that is above the surface of the moon. They are talking about various things which, placed at the distance from the moon to the sun, what temperature will those be? And you could measure the temperature of them. You could take a thermometer and you could touch it to a rock in space that's in sunlight, and you could measure that temperature. And you could point an infrared thermometer at a rock that's sitting in space, and you could measure the temperature on that rock. And there's another thing called a bolometer, where you can measure the electromagnetic radiation that is coming off something, if it's giving off temperature in other wavelengths. So when you were talking about the temperature in space, you're talking about the temperature of the object itself. And you're exactly right that when you think about what it's like to walk on a black sand beach, like your feet get really hot, or walk on the concrete or whatever, very different from the temperature that you feel when you walk on something that is white, that is cool. And even though they're both receiving the same amount of radiation, they're going to be different temperatures based on how reflective they are, how much they absorb the light, how much they're able to radiate the heat away, how much, in the case of Earth, right? How, what other methods are extracting heat from them? Are they wet? So on and so forth, right? So that is like a sort of an idealized temperature. You're imagining some, you're calculating the temperature that an average thing would be based on the amount of radiation that is falling on it from the sun. But the actual specific individual temperature of an object is going to change. And it's really amazing. Like on the moon, when you're in the sunlight, if you have a rock and you're measuring the infrared, thermometer on the surface of the rock, on the face of the rock that is facing the sun, you're going to see 120 Celsius. But then if you go and measure the shadow side of the rock, well, it's not going to be exactly. It's going to be about negative 130 Celsius. And that is just because the second you don't have that sunlight, then temperatures drop significantly. Now, with the rock, you're going to have the side of the sun face is going to warm up, and so it's not going to be as cold. But in the shadow of the moon, in the places on the moon that have never received sunlight, the temperatures get very, very low. And so whenever you ask what is the temperature of space, you got to specifically say the temperature of the thing that you're talking about, not space itself. Moon fart. I don't know what to ask. That was it. That was your question. Kamar Taylor 2902. Why is it harder to land on the moon than on Mars? Or is it? Actually, it is way harder to land on Mars than it is to land on the moon. And, we joked in the recent Space Bites just about how difficult it's been to land a spacecraft on the moon and how, the track record has not been good for the last several landers, only a few partial successes in a large number of landers. And like the Chinese had a successful landing, and then there was a failure from India and a failure from Japan, and then a partial success from Japan, failure from Israel, partial success from the US. So it's tricky. And yet the moon is the easy place to land compared to Mars. And I think, part of why this is happening is that you're seeing a lot of private spacecraft that are attempting to land on the moon for the first time. And so these spacecraft have just not built up the institutional expertise of developing a lunar lander. And then the various countries that have attempted to land on the moon have not built up that institutional expertise. And so you can't hire somebody who used to work at NASA and designed lunar landers to now work at your private space firm. Nobody in the Western Hemisphere has been building lunar landers, but the Chinese have. And that's been going really well for them. I mean, they have successfully landed Chang'es 1 through 5. I'm not sure how many of those were actually landings on the moon, but they've landed a ton on the moon. So, and so here's why Mars is harder, which is that on the moon, you don't have an atmosphere, right? And so you can just use a propulsive landing all the way down. And there's no atmosphere, there's no turbulence, there's no heating. You literally just have to calculate the right amount of fuel to use to land at the spot that you want to go. And you have to counteract your orbital velocity. And your orbital velocity is relatively low. You're going, let me see, what is it? Yeah, so your orbital velocity is relatively low. You're going about 2.6 kilometers per second around the moon. And that's what you have to counteract to be able to actually land on the moon when you're in orbit. And sort of compare, when you're in orbit on Earth, you're going about 7.6 kilometers per second. So it's a lot faster. And so Mars has an atmosphere. And also, when you arrive at Mars, you're taking this interplanetary trajectory where you attempt to essentially enter the atmosphere of Mars directly. And so you're coming in at more like 5 to 6 kilometers per second when you actually enter the atmosphere. And then when you do enter the atmosphere, it is thick enough to cause turbulence and heating. And so it sort of causes a lot of difficulty to your spacecraft, but it's not thick enough that you can use it to slow yourself down, use parachutes, and actually land safely on the surface of Mars like you can on Earth. Like with Earth, you enter the atmosphere, you get slowed down by the heat of the atmosphere, you deploy your parachute, the parachute allows you to just drift gently down to the surface of the Earth. On Venus, you just drop and you land gently on the surface of Venus. In hell, but at least it's easy to land on Venus. But on Mars, you enter the atmosphere of Mars, you deploy a way to slow yourself down, you slow yourself down with like an aeroshell through the atmosphere of Mars, then you deploy your parachutes, and you're still going too fast. And so you need some kind of propulsive landing on top of that. And so with the Viking missions, with the Spirit, Opportunity, with Perseverance, with Curiosity, they all use some kind of propulsive landing to be able to finally finish. Actually, with Spirit and Opportunity, they used airbags, which was pretty cool. So they were able to sort of blow up this airbag and then bounce around on the surface of Mars before they finally came to a stop. And so for the longest time, while there were various successful landers happening on the surface of the moon, from the Soviets, from the Americans, there was just a series of failures attempting to land on the surface of Mars. And they actually called this the galactic ghoul, where, like, to a certain point, 50% of the spacecraft that have ever been attempted to land on the surface of Mars had failed. But recently, the various nations have been building up that institutional knowledge, that they're learning how to dependably land on the surface of Mars. And so you haven't seen failures from the US. The Chinese were able to stick their first landing on the surface of Mars. So you're seeing people getting better and better at this. And so I think, we're in this really tough time right now where eventually people are going to get a lot better at landing on the surface of the moon. It's going to be when the private landers attempt to land on Mars, then the ghoul will return and start to gobble up spacecraft. What's going on? Okay. Okay, those were the questions that we had from the YouTube audience, or from the YouTube comments. So now we'll get into your questions. Old timer, you talked to Scott and Marcus. Everybody wants another debrief about Starship and New Glenn. So I haven't talked to them yet. I talked to them when IFT6 happened, and Scott was really busy, and so I was like, it's not like a big news story now. So I'm gonna wait until something sort of fairly significant happens. I'll probably reach out to them again when they attempt to capture Starship, try to capture Starship and capture Super Heavy. That's when we'll probably do another collab with Scott and Marcus. Paul Holt, I feel like we can see more of the Milky Way from the southern hemisphere. Is that right? It just depends on where you are on the southern hemisphere. So where I live in Canada, I can see the Milky Way. The Milky Way at various times of the year goes like directly overhead from my place. So I see, Milky Way from horizon to horizon. But the heart of the Milky Way, the place that has a lot of the most interesting stuff, the place with all the dust lanes and the very center of the Milky Way, is in the constellation of Sagittarius. And for me, that is always very low on the horizon. Sagittarius only appears in the summertime for me, and just gets above the tree line, above the mountains that surround me, and then I can actually see some of the objects at the center of the Milky Way. And then a couple of months later, it's dipped back over under the horizon, and then that's it for me for another year. But the one time that I was in Australia, we were in Brisbane, just north of Brisbane, on the east coast of Australia, and we were in a place with really dark skies, and the Milky Way was directly overhead. But the core of the Milky Way, the heart of the Milky Way, was directly overhead. And in fact, a bunch of the planets, for me, the planets again are sort of in this line off towards just above the horizon in the south for me. But when I was in Australia, the planets were directly overhead. I looked up, which then that minimizes the amount of atmospheric haze between you and what it is that you're seeing. And so I think it's just that it looks so much better from the southern hemisphere. And especially, when you're just slightly south of the equator, then it looks like really amazing. But as you continue south, as you move towards Antarctica, then you will probably see the center of the Milky Way start to be harder and harder to see, and so have sort of a similar version to what I do. So the best skies I've ever seen were in Australia. So I think just there's really good dark skies in the southern hemisphere. And Paul, you also asked about what's the best meteor shower in the southern hemisphere. They're not different. The north and the south see the same meteor showers. John Hoy, given no budget restraints in hypothetical world and limited to utilizing existing technology, which space mission would you sanction? So I mean, it's kind of a tricky question because I get there's no budgetary constraints, but I have to use existing technology. I mean, I think, anytime you want to take on a new mission, you have to have some technological risks. You've got to be attempting some new technologies that have never been done before. So I'm going to sort of assume that what you mean is like no magical technologies, no fusion drives that don't exist, and no warp drives and things like that. So, and I think, the thing that I would like to see most in my lifetime is a mission to the solar gravitational lens, where we can actually set up a telescope where we use the gravity of the sun as a natural telescope, and then we get a megapixel image of a exoplanet that would just allow us to see mountains and forests and oceans and cities on another planet that is hundreds of light years away. That would be mind-blowing. So that would be one of the greatest things that we could do. But I think, our current technology right now, we don't have any way that we know to get out to that kind of distance within a reasonable amount of time. We're talking about getting much farther than the Voyagers are right now in a decade, and we don't know how to do that yet. So I would say, I'm going to be kind of boring, but in terms of telescopes, I want to see a space-based interferometer. I want to see, 2 telescopes, maybe in a different wavelength, like near infrared, but that are operating on a distance. They are 100 meters apart. They are a kilometer apart, and they are in such perfect alignment that they can act as a telescope that is the size of the gap between the telescopes. And so it would be as if you had a telescope that is 100 meters across or 1,000 meters across or whatever. And there's some great ideas that you could deploy these on the surface of the moon, and you could sort of dial in their distances so they're absolutely perfect. And that would be just a huge leap beyond Hubble, Webb, anything that anybody is planning. And I think that is feasible. That is, it would cost in the tens of billions of dollars, and would require a lot of engineering challenges to build a proper space-based interferometer. But if we could do that, then we would be able to leapfrog to the next big questions, right? This is, now we're wondering about, are those volcanoes on that planet, or are those mountains? Right? Those are the kinds of questions we could be asking. When right now we're still at the point where we can't even necessarily observe any specific exoplanet, and we definitely can't directly image Earth-sized worlds orbiting around sun-like stars. So that would be great. And then I think in terms of planetary exploration, I think I want to go to Enceladus, and I want to have a lander drop right at the tiger stripes at the south pole of Enceladus. This is where water is being hurled out into space. And so you could actually go and sample that water and search for some kind of evidence, organic molecules, evidence that life exists under the ocean in Enceladus, and maybe even send a probe down, right? You could actually go down into those tiger stripes against the flow of material that's coming out and try to get down to the ocean down beneath and explore it directly. And, that kind of technology, all the bits and pieces have been worked out, but it's just too complicated, too expensive to actually pull that off. So I think those would be 2 of the most interesting things that we could do here in the solar system in this sort of feasible future. Hooves, what is metallic hydrogen? So metallic hydrogen is essentially what you get when you put hydrogen under enormous pressure. And not just like put it in a vise, but like put it in the heart of Jupiter. And so when you think about Jupiter, Jupiter is actually this enormous, massive blob of hydrogen and helium and other elements that has, it is essentially the mass of all of the planets in the solar system, right? Like most of it is in Jupiter. And all of that that mass is pushing down and causing this incredible pressure. And at the high points of Jupiter, when you're close to the cloud tops, then it is like this light fluffy gas. But as you go deeper and deeper, then the pressure increases, and eventually it's like as dense as water, and then it's as dense as iron, and eventually you get this form called metallic hydrogen. And it's never been directly observed because it's trapped down in tens of thousands of kilometers of Jupiter, but we know that Jupiter has this incredible magnetic field, very powerful. And this is caused by hydrogen that has been turned into a metal. And then the metal acts like a dynamo at the heart of Jupiter that is then sort of rotating and generating this enormous magnetic field in the same way that we have a rotating ball of liquid iron at the middle of the Earth. Jupiter has a rotating ball of metallic hydrogen that is causing that. And there have been some recent claims that people have been able to actually make metallic hydrogen in the lab. And so I say, well, you can't just make it in a vise, but in fact, that's how they make it. They make it in a vise. They have this thing called a diamond vise where they're able to concentrate enormous pressures at the very tip of this vise. And they have claimed that they've been able to actually make metallic hydrogen. They're able to crunch hydrogen down to the point that it actually behaves in that same way as the stuff that's down in the middle of Jupiter. And it would be a game changer. Like if we actually could produce metallic hydrogen, then it is an energy dense fuel like nothing we've got down here on the surface of Earth. And so you could have spacecraft that could just like take off, land, right? And you wouldn't have to have like giant refueling. You wouldn't have to have booster rockets, all that kind of stuff. It's just that the fuel would be so dense, it would be able to allow you to get around the solar system. It's sort of in the way science fiction has always told us it should be. There was something else I was going to say about metallic hydrogen. Right. But the other thing is we just don't know if metallic hydrogen is stable. Like when you force metallic hydrogen down into that form, does it just remain? Can you then remove it from the vise and then put it in your, I don't know, in your spacecraft and have it sit there until you need it? Or will it immediately want to expand back out into a liquid form or a gaseous form as soon as you take the pressure off? And so, like, can you maintain the pressure inside your spacecraft to keep the metallic hydrogen tiny and dense? Because like if your containment doesn't work, then the thing will detonate your spacecraft. So metallic hydrogen is really exciting, and I'm really looking forward to more research as people attempt to recreate this in the lab. Not only because it could be a potential source of storing energy, like the best possible battery, but it also teaches us a ton about what's going on inside worlds like Jupiter. Snowy fields. Besides Betelgeuse, are there any other possible supernovae that we could see in our lifetime? Absolutely. On average, a star goes supernova in the Milky Way about every 100 years, and we're overdue. The last supernova that's been seen sort of in recorded history was in the 1600s, and that was Tycho's supernova. And since then, there's been no recorded explosions of supernova. The closest one that we know of was the one that went off in the Large Magellanic Cloud back in 1987. And so that is, oh man, like almost 50 years ago. Is that right? I'm so old. I remember it. What was I? I was 16 in 1987. Yeah, 16. Anyway, so it'll be 40 years ago. Yeah, that's not so bad. So anyway, so that's the most recent one we've seen. And that's like 165,000 light years away, which is very far away. When you think about Betelgeuse, it's like 640 light years away. So that's very close. But there are plenty of potential candidate stars that could go supernova. There's at Carinae. There's a bunch that are much nearer than in the Large Magellanic Cloud. And any one of those could go off. They could happen at any time. I mean, Betelgeuse could have already gone off sometime in the last few hundred years, and we just won't find out about it into the future. There's like a 1 in 4,000 chance that Betelgeuse has already gone off, and we just haven't seen it yet. But like when these things go off, like if Betelgeuse went off, it would be ludicrously bright. I mean, it would increase in brightness by like a factor of 7,000. It would be as bright as the moon in the sky, like a full moon or like a quarter moon. You know, sort of people argue about how bright it would be, but it would be very bright, visible in the daytime for months. And that would be really impressive. You know, you could read by it. But even like farther away, various supernovae that are 10,000 light years away, they would be very bright. You would see it be one of the brightest stars in the sky, and would be very impressive. So we wait and we hope that we're due. There you go. 87. I'm not 40. No. So let's see. So 16. So you would be 38, right? 7, 97, 07, 17, 27. Yeah, space is hard. That's hard. Kevin Patrick, did you see the video of the meteorite striking the sidewalk in a home in Canada? Yeah, that's crazy. Saturn II. Could we see any astronomical objects in 3D if we took spectrographic pictures of them while the Earth is on opposite sides of its orbit? Has this ever been tried? So, I mean, that's really interesting. So the method that you're talking about of taking images from either side of the Earth's orbit is called the parallax method. And this is the method that astronomers used first to measure the distance to various stars. If you go back, it's funny. So the ancient Greeks were like not sure that the sun or the Earth was at the center of the solar system. And so some people believed that the Earth was at the center, and other people believed that the sun was at the center. And the reason that they gave up on the idea that the sun was at the center was that they couldn't measure this parallax. They said, if the sun is at the center of the solar system and the Earth is orbiting around the solar system, then when we look out into space and we look at the stars, we should see the stars jumping back and forth in the sky every 6 months as the Earth goes on either side of the sun. And we don't see that. Therefore, the Earth is in the center of the solar system. And they were so close because it was just that they couldn't measure the parallax with the tools that they had available. They didn't have telescopes back in Greek times. But now we do. But anyway, that's like a crazy tangent. But like my favorite mission, Gaia, which was recently, they shut down the science operations, used this parallax method and was able to measure the positions of 2 billion stars in the Milky Way because they had a very good telescope and they were able to do these accurate parallax observations. And so what you're asking is like, could you do a parallax observation of a nebula and then take those two versions of the parallax and actually try and make a stereoscopic image that shows you what the thing would look like in 3D? And, you know, I think various kinds of those observations have been made, but I don't think they would get you this, you put on the stereoscopic viewers and see the nebula in thrilling 3D. But people have made three-dimensional images of various nebulae, and they just use different techniques to be able to figure out the distances to different structures in the nebula. But they also use that parallax method. So they'll calculate, when they look at the pillars of creation, and they'll calculate how far away this pillar is, this spot in the pillars of creation versus that spot versus this spot. Or they'll look at these really cool planetary nebulae, which look like rings, but actually in many cases are more like slinkies. They could be cylinders, they could be weird geometric patterns, and they're able to actually measure the structure, the three-dimensional structure of those objects, and then sort of calculate what they would look like. And so there's some really cool, and I hope Chad is playing some. There's some really neat visualizations that have been done where people have calculated what some of these objects would look like in 3 dimensions. If you could like fly through the Orion Nebula and things like that, what it would look like. Jim Les, do you think the idea of Cascadia is hitting home with Western states these days? Your thoughts? I have no thoughts. It's going to be a interesting couple of years. Treestone Simino. Is it possible to not... Treestone Simino. Is it ever possible to not be moving at all somewhere in the universe, or is something always acting upon you? Whenever you talk about, is it, are you moving, you have to always ask in relation to what? So, I am not moving in relation to this camera, but this camera is moving in relation to the moon. And so then there is a velocity difference between those two things. And so you can measure your velocity in various ways. So for example, the Earth is turning at 1,600 kilometers per hour. And compared to if you're outside of the Earth is going around the sun at 30 kilometers per second. And so that's just in relation to the sun. The sun is going at 220 kilometers per second in relation to the center of the Milky Way. And the Milky Way itself is moving at 600 kilometers per second in relation to the cosmic microwave background radiation. And so no matter where you are, you're going to be moving in relation to something else. And so it all just depends on compared to what. You have to measure, you have to say, are you moving compared to what? And so some things you're moving, some things you're not. But in general, everything is moving compared to everything else. M. Why is it that when the sun is rising, it's bigger and more colder and cooler than when at 1 p.m. the afternoon is smaller and hotter? So this is an illusion. The sun is not bigger when it's at the horizon, when it's rising or when it's setting, than compared to when it is high up in the sky. It is exactly the same size. And the same thing goes for the moon. Like, have you ever gone out and the moon is just rising and the moon looks enormous? And then later on, you go outside and you look up and the moon is teeny tiny and you're like, wow, why is the moon so much? Isn't it crazy that the moon looks so much bigger when it's on the horizon than when it is high up in the sky? Well, the reality is it is exactly the same size. And this is a weird trick in our brains called the moon illusion. And I guess there's also the sun illusion. Why does this happen? We don't know. But it seems that it has something to do with when we see something like the moon, where when it's high up in the sky, our brain kind of has no context. And so it sees it in the size that it actually is. But when it is down near the horizon, you're seeing it compared to buildings and mountains and trees and things like that. And so your brain tries to size it based on what it knows to be the sizes of those other things. And the way to show that this is really just an illusion is check out the size. And the one that I like to use is your little finger, your pinky finger, nail. And the moon and the sun, but with the sun you'll hurt your eyes, but with the moon it's safe to do, is because they're the same size in the sky. But the moon is the size of your pinky held at arm's length. So you hold out your hand, right? You look up at your pinky and you hold your pinky next to the moon, and you'll see that it is exactly the same size as the moon. And then do this when the moon is down at the horizon, and then wait many hours or another night, wait, and then do it when the moon is really high up in the sky, and you'll find that they are exactly the same size. And there's great pictures that have been taken where you can see the moon. They take a new exposure of the moon every couple of minutes. You just get moon, 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 and it stays exactly the same size. And same thing with the sun. So yeah, your brain is lying to you about the difference in the size. Leafbinder, Fraser, you're going to do a telescope viewing this week. Yeah, so good news. The planetary scope is ready, and I did some training on the new telescope. The seeing wasn't great, but I was able to see the Great Red Spot on Jupiter and see bands across the planet. I could see the dark regions on Mars. I could see the rings of Saturn, a bunch of the moons of Saturn, the moons of Jupiter. So we are waiting for some better seeing, and I will do some test observing nights probably later on this week. So yeah, stay tuned for that. Wait, what? Did you ask the same question? Okay. Sorry, just looking for questions. Adam Redwine, launching near the equator saves some energy, but what if you want a circumpolar orbit? Would you want to launch from a higher or lower latitude? So right. Okay. So as you said, when you launch from the equator and you're moving in the same direction as the equator, then you get to take advantage of the orbital rotation of the Earth, and that allows you to save a certain amount of fuel or be able to launch a heavier payload. I mentioned, the speed, the Earth's rotation is 1,600 kilometers per hour, and so if you launch a rocket, you get a free boost of 1,600 kilometers per hour as long as you want to go into orbit in the same direction around the equator. But if you want to launch any circumpolar orbit, then you're going to want to cancel out that sideways orbital velocity and then be able to launch more north-south. And yeah, the farther north or south you are, then the less of that sideways orbital velocity you have to cancel out. And there are several launch facilities that are, the Russians have, the Russians did a lot of polar orbits. There are US facilities, and actually they're planning on building one here in Canada that will be ideal for doing polar orbits. But you can still do a polar orbit from from the equator as well. It just requires, you have to cancel out that sideways, or maybe you want it, right? So that the Earth is going to rotate underneath you, and you're going to be able to then orbit around from pole to pole and be able to see all of the Earth. There's a lot of other really interesting orbits that people have come up with. There's like sun synchronous orbits. There's a thing called Molniya orbits, ways that you can actually just go around the Earth, retrograde orbits, ways that you can get geostationary orbits. So there's a lot of really cool orbits that you can use depending on what you want to accomplish with your spacecraft. And there are different places to launch depending on what you want to do. Oh, there you go. Spaceport has already started in Canso, Nova Scotia. So yeah, it's in Nova Scotia. I totally got to go to that. That'll be so cool. Serenity. Why doesn't Blue Origin televise their booster landing? Are we just taking their word for it? Well, I think Blue Origin wanted to televise the landing for their booster, but the booster failed. And so we didn't see it land. They lost signal with it and it broke up. It was really too bad. I mean, SpaceX has so much experience in broadcasting their launches that we've just all become super accustomed. We saw that with Flight 7, where they had a drone that was hovering above where the rocket was taking off, and you got just the perfect view. The rocket as it went by, you got great telephoto lenses, you got a great drone shot as the rocket was coming in to do its landing. Like, they had something like 30 cameras on the rocket itself to sort of take views of it from every perspective and to analyze it. And Blue Origin just doesn't have that experience. I mean, they've launched a bunch of New Shepard launches, and they should know better, right? They should know how to do this, which is that, they see what SpaceX does and just copy that. But yeah, we just didn't see the same level of cinematography in Blue Origin. And I think that's really important. And I hope that if Blue Origin is planning on launching more rockets, then they should really double down on cinematography. Let's get drones capturing the launch. Let's get really good cameras on board the booster as it's coming down. Like, even if your booster tears apart, I want to see that coverage in real time. So if you're watching Blue Origin, beef up your broadcast so that we can see every part of it. Can a submarine operate in orbit? Not in the same way. I don't have the math in front of me. Waka Waka, could we hitch a ride and core into a long period comet and then make the comet a spacecraft or an observatory? The problem with attempting to hitch a ride with a comet is that you've got to be able to launch your spacecraft and boost it up, increase its velocity to match the velocity of the comet that you're attempting to hitch a ride with. And so once you've done that, once you have expended all of that fuel, then there is no need to hitch a ride because you're now going the exact same speed as the comet. And so then you could be orbiting around the comet and discovering all kinds of things about it. Once you attempted to land on the comet, which is very tricky, we saw the European Space Agency tried that with their Rosetta mission, with their Philae lander. Didn't go so well. It's very hard. It was very tricky to do that with both OSIRIS-REx and with the Hayabusa 2 mission. That the cometary surface is crumbling and cracking, and it's got fissures and things are happening. Like, it's a very dangerous place to try and land a spacecraft. There's no benefit, right, to hitch a ride. And so then, could you make the comet a spacecraft? Yeah, I mean, you've landed on a comet, and there's plenty of things to do to study the comet, but you haven't made it a spacecraft. And you wouldn't want to necessarily make it an observatory because the comet is surrounded by this coma of all of these particles that are outgassing from the surface of the comet. And they're going to be surrounding your spacecraft, and they're going to make it they're going to turn it into a very bad platform to be an observatory. So there is no free ride. No free lunch. Shalab Meta. Gaia's role in the distance ladder calculation? Question mark, question mark, question mark. So Gaia is one of the most important roles in the distance ladder. It is the foundation of the distance ladder. And so, if you don't know what the distance ladder is, this is this way that astronomers measure distance in the universe. And there are methods that work very well for things that are relatively close to us. There are methods that work well for things that are farther away from us, and then farther away from us, and then farther away from us. And then the trick is that all of these different methods overlap with each other. And so you can use them to double check one another. And this idea of using the distance ladder goes all the way back, more than 100 years, back to when, was it Vestal Slifer? Right. So we knew that the parallax method allowed you to measure the distance to various stars and calculate how far away they are from you. But that only gets you a few thousand light years away from the Earth before the distances that these stars are moving when you're on one side of the sun to the other side of the sun is so small that you can't measure it. And so you can't measure the distance to that star. And so there's this like sphere of radius around the Earth where the distance ladder begins and starts with the parallax method, and then it maxes out. But fortunately, there's a type of star called a Cepheid variable, and they are closer than the parallax method ends. But also, these Cepheid variables are very large, very bright, and they're visible not just in the Milky Way, but even in other galaxies. And so so you can double check. You can calculate the distance to a star, a Cepheid variable, using the parallax method with Gaia, for example. And then you can measure the intrinsic brightness of the Cepheid variable, and you can use it to calculate what its distance is, and you make sure that those two distances are the same. And then now you're measuring Cepheid variables out into Andromeda and into other galaxies. And that's what Edwin Hubble did to measure the expansion of the universe. Was he was measuring the redshift of various galaxies that had these Cepheid variables in them. And then the next overlapping thing is Type 1a supernova. And then you've got the cosmic microwave background radiation. And there's a whole bunch of other distance methods. There's about 20 that you can measure, and they overlap. And so you can sort of build up this distance ladder that gets you from here to 5-6 billion light years away. And then there's this gap. And then you've got the distance of the cosmic microwave background radiation. And so the astronomers are really trying to figure out that gap between the CMB and where the Type 1a supernova end. But Gaia was the foundation, and by providing the most accurate parallax measurements that have ever been provided, it fine-tunes the entire distance ladder because the rest of it depends on the parallax method. So a bunch of people are asking about my opinions of timescapes. So Space Mog just did a great video about the timescapes model. So you should definitely check that out. I talked about this last week. Leaf Binder, Fraser, what level are you in Path of Exile 2? And how do you find the time to even play, bro? You're as busy as Elon. Um, oh, I don't want to get in trouble with Elon Musk here, but I actually play my character. So I'm level 75 in Path of Exile, and I think in Path of Exile 2. And so I completed the campaign, and I've probably done about 30 maps at this point. And I don't really have a lot of time. But the problem is, at the same time that Path of Exile 2 dropped, Project Zomboid's Build 42 dropped. And so I've put in roughly the same amount of time into both Path of Exile 2 and Project Zomboid. And then also I'm like looking at the Caves of Cud and going like, oh, should I buy that and play that? I don't have time to play, but I love to play games, and so I play. So one thing that I've been doing recently is I hooked up a Windows machine to my treadmill, and then I'm able to be on the treadmill and play with a controller and be able to play a game. And it makes the time on the treadmill just vaporize. You don't even notice that you're on the treadmill, and you played a game that you really enjoyed. I've been playing Slay the Spire, which is sort of like not too like too careful with the controller. So but yeah, it works really well. Zomboid multiplayer now? Yeah, I would love to. So Build 42, man, this is like too in the weeds for video games here for people, but the new version of Project Zomboid is really good, but it has no multiplayer, and so you have to play it solo. But I can't wait for there to be multiplayer. That'll be a lot of fun. GD Shanahan, thanks for the answers, Fraser. What are the windows to Mars? If someone was stuck on Mars and needed to get home, is there time when it would be better to wait than to try to come home? So when you think about the orbital speeds of the Earth and Mars, Earth and Mars line up on the same side of the sun about every 2 years. But it's not like, and that's like roughly when the window is to launch to Mars, but not exactly. And so what you do is what's called a Hohmann transfer. And so you launch off of the Earth and say you're in orbit around the Earth. And then you fire your rocket so that you create a elliptical orbit around the sun where the line of your orbit crosses the Earth and crosses Mars where it's going to be in its orbit. And then you follow this trajectory. So you fire your engines, you get to the point that you've created this ellipse that you're now following. And then you just coast. And you arrive at Mars. And that is like the minimum amount of energy that's required to be able to get to Mars. And so you only need to be able to give your spacecraft like a delta V of 6 kilometers per second. And so it's relatively efficient to be able to get to Mars that way. But this Mars window only opens up every 2 years. Now it opens up for a couple of months, but there's like the perfect time when you can launch to Mars with the absolute minimum amount of fuel, but you can launch a little earlier, it takes a little more fuel. You can launch a little later, it takes a little more fuel. But eventually sort of the amount of fuel is beyond what your spacecraft is capable of producing. But it all depends on how much delta V your spacecraft is capable of generating. If you have more propellant, you're willing to throw out the problem. If you're willing to toss out your payload, you're willing to try and go a lot faster, then you can extend that window farther either way. And so, but really, to launch not during one of those Mars windows is kind of crazy. And so if you're stuck on Mars, then it's the same thing, which is that there's going to be this ellipse you're going to want to launch on, follow this Hohmann transfer that where the ellipse brings you down into the inner solar system, and that line crosses the Earth. And so, same thing every 2 years. And so, yeah, if you are on Mars and is not the time for the window, you're going to have to wait until the window opens up. You're looking at up to 2 years to wait for the next Mars window to open up. And so the Mars windows have traditionally, for the last decade or so, been on the even years. So there was a Mars window in 2024. The last one was 2022. There was one in 2020, one in 2018. The next one will be in 2026. But just to show you how it's kind of drifting is the upcoming Mars Escapade mission, which is going to be launching on a Blue Origin New Glenn, launches in March. And it was supposed to launch back in October or November, but they were still finalizing the spacecraft and wasn't ready. And so the very end of this, the last, like the point where they will no longer have the propellant to be able to get this spacecraft to Mars is in March of 2025. So they've got just a couple of months to get the spacecraft, to get the rocket ready and actually launch the spacecraft to meet the window. Otherwise, they'll have to wait. And this is what you saw with the Rosalind Franklin rover that's going to Mars from the European Space Agency. Originally, they're going to launch, I think, 2022, and then there were some problems. They decided they were going to launch 2024, and then there was Russia's invasion of Ukraine, and Russia was providing the launch vehicle for that mission, and so that fell apart, and so NASA is taking over, but now it's pushing it to 2026. So you have to follow these windows if you want to be able to go to Mars with a reasonable amount of fuel. Where are we at to? 11:07. Okay. Alex Patulny, how long is it physically possible for a crowbar in space to exist, especially if no other matter were to get in the way? Could you have one a light year in length? So are you asking how long physically would a crowbar last in space, or how big of a crowbar could you make? So I'll tackle both of those questions, I guess. How long would a crowbar physically last? We don't know. But when we think about, say, the Voyager spacecraft, they have the golden records on them, and the golden records are in a protective case. And it's believed that the golden records should be playable about, say, 500 million years from now. I mean, they're going to be constantly eroded by space dust, by cosmic radiation, they'll be worn down, and yet they'll still be playable that far into the future. So you would be looking at billions of years. You know, if you had a crowbar that's made of metal, it's going to be getting hit by cosmic radiation, by space debris, dust, things like that. It's going to get worn away. Eventually, it'll just turn into dust. But you're looking at billions of years before your crowbar erodes away. How long could your crowbar be? Could it be a light year in length? So the problem is it depends on how much material is in the crowbar. If you have a crowbar that is like the thickness of a regular crowbar, it's not very big, it's not very thick, and yet you're going to have this thing be a light year in length. Any kind of gravitational disturbance is going to start causing ripples in the crowbar, that it's going to start to bend and torque and twist in various directions as it is attracted to various objects of gravity across 1 light year. And I think eventually you're either going to twist up your crowbar a bit, or just it's going to flex back and forth enough times that it's going to start to, the metal's going to break and your crowbar is going to float away into multiple pieces. So it can't last forever, but it could, it could last for a while. Cloud People Records. Is the Canadian space program at risk in the upcoming political environment? I don't think so. Canada has a space program. We have funding for various projects. We've got a lunar rover that's under development right now and will probably launch to the moon in an upcoming flight. We have several astronauts who have spent time on the International Space Station. One of the astronauts is due to fly with the upcoming Artemis 2 mission, which is supposed to launch in 2026, which is just a little over a year and a half away from now. And then we have various research projects. We contribute instruments to various spacecraft. There's collaborations with many countries around the world. Obviously, one of Canada's largest partners is the United States. But we have, we work with many nations. So, the question is, when I can think of sort of things that might cause a direct impact. So one would be, let's say the Artemis missions get canceled for some reason, which I can't see that happening. President Trump originally was the one who announced the Artemis missions, and so this is his legacy. This is the thing he wanted to see done. So hopefully that will continue, and so a Canadian astronaut will fly to the moon. And Canada has contributed a instrument to the James Webb Space Telescope, and it's expected that that mission will continue. So that's done. The arm, the mobile servicing arm on the International Space Station is built by Canada. In theory, Canada is going to work on a version of the Canadarm for the upcoming Deep Space Gateway. And I can expect that the Deep Space Gateway could get canceled if, certain people have their way, but we don't know. So right now, as I said last week, we have no idea what's going to happen. Right now I'm recording January, in my time, it's January 19th. So one day before inauguration, we have no idea what's going to happen over the next 4 years. But I'm not super freaked out. I just need to, as it relates to Canada, we will not panic, just deal very carefully and cautiously and friendly, apologetically, but also forcefully with whatever comes our way. And I think, for everybody out there, we just have to watch and wait and not overthink this and just think logically about, what happens next. When can we play ice hockey on Titan? I don't know if we can, because it might be too cold on Titan to be able to actually from what I hear, we don't entirely know how ice skates work, but that, the pressure of your weight on the skates creates this little bit of fluid, melts a little bit of water underneath the ice, underneath the skate, and that's what causes the loss of friction, allows you to skate. And so on Titan, the ice is so cold that it might not be able to freeze, but also the low gravity, you're not able to push down with your weight. And so we might not be able to skate on Titan, which is sad. Yeah, heated skates, weighted heated skates, maybe that would do the trick. I'm obviously if we go to Titan, we will figure out how to be able to skate on Titan, because that would be awesome. So it's just a matter of it's an engineering challenge. We'll figure it out. Chris Nilsenels. What efforts are being made to discover stars similar to our sun, or stars that were created alongside the sun in such a hypothetical stellar nursery? Plenty of work is being done to try to find the stellar siblings of the sun. And there's sort of like two main things that you're looking for. The first thing is that you're looking for stars that have a similar sort of path that they're taking around the Milky Way to the sun, sort of similar distance from the center of the Milky Way, similar orbital trajectory going around the Milky Way. And thanks to Gaia, right? The Gaia mission is the one that has mapped out all of these stars, and they found many stars that have very similar trajectories to the sun, and so could very well have been stellar siblings of the sun, 4.5 billion years ago. And then the second thing is to analyze the chemical composition of various stars. And so there are other surveys. Oh, I forget the name of the survey. Carmenes? Anyway, there are various surveys that are looking at the chemical fingerprint of various stars, and they're looking for stars that are very similar to the sun. And there have been several candidates, at least one for sure, that has almost the exact same chemical characteristics as the sun and has a very similar orbital trajectory as the sun. And so it's believed that that is one stellar sibling of the sun, but there would probably be hundreds of other stars, if not thousands, just moving around the Milky Way that were once part of the same stellar nebula that the sun was. Yeah, Natalie Vincent, I believe the fluid layer theory was recently disproved. Yeah, I think that's true. So that's why I was sort of like tentative about that. Zachary Wilson. Now we're like, all we want to think about is skating on Titan. Would the hydrocarbon lakes on Titan even be frozen enough to be stable? So the hydrocarbon lakes, no. The methane is liquid methane, so you could swim in it, but you couldn't skate on it. But it's just that the surface of Titan is ice. That the mountains are made of ice, the rocks are made of ice, that everything is ice, water ice. But I love that question. Curling on Europa. That'd be awesome. Turn Europa into just like a giant curling rink. Adam Redwine, what other space sports are there? Basketball on Mars. Yeah, I covered this question a couple of years ago and sort of brainstormed various space sports. Like on Titan, you could fly with wings. So you can imagine sports games where you could be flying around with wings on, attached to your arms. But even in zero gravity, think about like Ender's Game, where they had zero gravity games that they were playing. So there's a lot of cool ideas that you could do for sports games that would be totally different and would be pretty exciting. I mean, just like the moon, low gravity games on the moon would just be mind blowing. People could jump 6 times higher on the moon than they can on Earth. Yeah, baseball. You could hit. You could hit like 6 times farther, right? Cloud People Records. What was so bright straight upwards that it was shining through the cloud cover in southeastern Ontario a couple of hours ago? Venus? Venus is really bright right now in the, but that's in the western sky. In the eastern sky, Jupiter is really bright. That's probably what you're looking at, was Jupiter. Trayman, do we live in a void? No. We're in the opposite of a void. We live in the concentrated area of the galaxies. Nomad 77CA, could you please explain the Aldrin cycler idea for travel to Mars? Sure, this is an idea that's been proposed by Buzz Aldrin, and the idea is that you would, instead of sending a new spacecraft to Mars to carry your astronauts, that you would have a spacecraft that is making a circuit from the Earth to Mars and the Earth to Mars and back and forth. And that if you sort of time the orbits well and you have a very efficient engine on the cycler, like an ion engine that is capable of producing thrust over a long period of time, you wouldn't have to use a lot of fuel to be able to maintain this cycle back and forth. You're sort of imagining there was like the perfect orbit that where you follow this elliptical orbit and you leave Earth and you get to Mars and then you follow and then you go around Mars and then you come back and you end up at Earth and you go around Earth and you end up at Mars. You can sort of complete those circuits back and forth, but you will have to make some regular adjustments to the spacecraft. And so the astronauts could launch off of the Earth in a relatively small rocket, just enough to be able to get them to the cycler. And then the cycler has tons of fuel and it's big and it's got maybe artificial gravity and it's got all of the resources that they're going to require. It's like a hotel that is flying through space. And then they spend their 9 months on the cycler. And then when they arrive at Mars, they can then leave with a descent vehicle or can go to, say, the Phobos station, and then the cycler does its swing around past Mars. It comes back towards the Earth, and maybe some astronauts who are on Mars get on the cycler, and then they get to go on the return journey again in relative comfort until they arrive at Earth, and so on and so forth. And it's a great idea, and it feels almost inevitable that in the far future, if we're going to send large groups of people to Mars on a regular basis, then you are going to want to have this spacecraft. And they actually covered it kind of in The Martian. If you remember the movie The Martian, the spacecraft that was carrying them to and from Earth and Mars was kind of like a Mars cycler. Or it was exactly a Mars cycler. James Rockwell, is stellarium accurate? Absolutely. Stellarium is amazing. Even like into the far future. Like you can look at what the positions of the planets will be in 2300. Nitro 57 MI. Has James Webb determined if the universe is other than flat? No. The universe is still flat. And James Webb won't be the telescope that'll do it. You're looking for something from the Euclid mission or Vera Rubin or Nancy Grace Roman. So got to wait for those spacecraft to maybe take another crack at that. Drew D, when humans set up a Mars colony, how will we develop an internet on Mars? That seems pretty important. Can we transfer Earth's internet? So Mars is far away from us, and in terms of light minutes, it's like at the closest point, it's like 4 light minutes away from us, and at the farthest point, it's like 20 light minutes away from us. And so anytime you're attempting to communicate any information to Mars, you have to wait that communications time, the lag, right? The ping times. They're going to kill you. While if you're trying to be playing like CSGO against somebody, and you've got to wait 4 minutes for every single packet of information. You're gonna be not doing great at the game. So will they have an internet? Absolutely. But you're gonna imagine they're gonna have a local internet where they're able to communicate in relatively real time on the surface of Mars. Are probably going to have some kind of satellite infrastructure that is allowing them to communicate. And then they're going to be transferring data in bulk back and forth with Earth and maybe other planets in the solar system and the O'Neill colonies and things like that, right? But they're going to have to send these in with, constantly streaming information, but it's going to be on that long delay. And so certain kinds of activities, like, you want to do a Google search on the live information that's back on Earth, you're going to have to wait 4 minutes or 20 minutes for the results of your Google search, right? What is the distance to the moon? And then you wait, and then 20 minutes later, the answer pops up on your computer. But for example, say you want to stream a movie, you probably will cache it. So a new movie will be released on Earth, and then it will be transferred to Mars, and then it will be cached on Mars. Anybody who wants to watch the movie is going to watch it from the Mars version. And so it's just that real-time stuff. And so the things that will be infuriating will be like doing real-time chat. Like if you're trying to text message somebody who is interplanetary, you're going to have to wait those, every single message back and forth. You're going to have to wait. It's going to take you an hour to say 3 things back and forth, to be able to do like a video call or, things like a telephone call. All of that's impossible. But you can imagine that there will be these constant data streams that are updated. They're synchronizing the Earth internet with the Mars internet with all of the relevant data that's important. Like Wikipedia will be 4 minutes late on Mars than it is on Earth, or 10 minutes late, right? But they'll be synchronizing and trying to keep everything up to date. So it will be critical, absolutely. And there'll be certain things where you really, it'll feel like you're cut off, right? If there's an emergency and you have to call back to Earth to try and get some instructions to do this thing, you're going to have to wait. Every time you ask a question, you have to wait. Round trip time. You send your message. Your message takes, I don't know, let's say it takes 10 minutes to get to Earth. And then you wait for their response. And that takes 10 minutes to get back. So now you're looking at double the time, 20 minutes just to get one answer. And it could stretch all the way to almost 40 minutes. So it can be pretty bad. But other times, if it's just you're looking at reference material, things like that, checking up on the news, it'll all feel instantaneous because it's all being sent in bulk between planets. Early rains. Can we communicate with Mars at all if Mars is on the other side of the sun? We can't, no. When Mars gets really close to the sun, it enters this blackout period from the perspective of Earth. And so on NASA spacecraft or NASA communication systems lose contact with the spacecraft, and then they wait until Mars has come out the other side of the sun, and then they're able to restore communications. But that's because we're on Earth and we're attempting to communicate with Mars. But you can imagine some future where there's more infrastructure, and so maybe while we aren't able to communicate directly with Mars, we'll have relay stations at the L4, L5 Lagrange points, and they can relay communications. So we send a communication to the relay can then send a communication to Mars, and then it sends back to the relay while we don't have that direct contact with Mars. Thanks, Leafbinder. Back to leveling. What are you're leveling on Path of Exile? People are asking me if I've seen the videos of the Starship debris over the Caribbean Islands. I have. Yeah, we're going to talk about that in the next Space Bites. We had to wait. We did Space Bites. We held off, normally we record Space Bites in mid-morning on Thursday, but because of the launch of Starship, it was like 2 o'clock. So we held off the recording, and then as soon as we learned the fate of Starship, we recorded the episode. So we were like, everything was ready, everything was prepped and ready to go. And then as soon as we learned what happened, like we would have been even later if Starship had survived. And then, after we'd already recorded and Anton was starting to edit it, we saw the reports of the debris. And the problem is, like, I really try to respect the rights and ownership of stuff. So just because somebody posts a video, well, there's two parts to this actually. So the first thing is that when you let me this is going to be a mess, Chad, but okay, don't worry about it. Yeah, so there's two parts to it. One is that whenever there are spacecraft that are re-entering the atmosphere, someone will post hoax images of re-entering spacecraft to Twitter and things like that. And there was like a European Space Agency cargo vessel that re-entered the Earth's atmosphere, and they knew where it was going to happen. And so they sent an airplane out and they took images of it was coming through the atmosphere, and they look amazing. And then every time a new satellite re-enters the Earth's atmosphere and we don't know where it's going to happen and when it's going to happen, somebody will post that picture and go, oh, here's the new satellite, here's the satellite re-entering, and people will repost it, but it's just fake. It's just, it's an old image. And so you have to be super skeptical whenever you see stuff like that. It can be AI fakes. It can be just fake images. But then the other thing is you have to respect the intellectual property, the ownership of the people who posted those pictures. And I think, you're going to see a lot of people put those video clips into their videos. Well, like, did they negotiate the rights for those videos? Are they paying for them? Are they paying the people who are in the Caribbean island? I think they just took them, right? Like, people just like see them on Twitter, they download the video, and then they put it in their own video. And that's kind of gross. So, we'll probably talk about it. We may not even talk about it, but we probably won't even put the images in our video just because, I want to respect the rights of the people who took those videos, and, hopefully they're getting paid by NBC and things like that to post their videos. Yeah, I mean, you could say if it falls under fair use, but I don't really think so. It's fair use is like kind of tricky, and it sort of depends on, if I was reporting on, like, it's kind of tricky on when you want to make that fair use defense. But even so, I sort of I don't think it gives you a get out of jail free card, right? Where you're like, well, just because I can post that person's picture or video doesn't mean that I should. So, I prefer to lean on stuff that is in the public domain, stuff that we have expressed written use of, stuff that I've negotiated the rights for, things like that. Where are we at? 33. Yeah, thirsty tonight. XX Philip XX6541. What are the potential pros and cons of launching rockets from a mobile launch ship like the Chinese are experimenting? What are the potential pros and cons of launching rockets from a mobile launch ship like the Chinese are experimenting with? Would it have to be a solid fuel rocket? Right, so the Chinese are experimenting with launching rockets from the ocean, and the advantage is that if you can launch directly from the equator, you get to take advantage of the Earth's rotation. It gives you that bonus 1,600 kilometers per hour of orbital velocity that allows you to either launch with less propellant or carry a heavier payload to the same orbit. And most of the time, rocket launch sites are as close to the equator as you can get, but still be reasonably accessible on your land. And so, for example, in the US, they launch from Florida or they launch from Boca Chica. Those are places that are quite far south in the US, but they're still pretty far away from the equator. But you still get most of the advantage. You don't get the full velocity advantage, but you get a lot of it. China isn't as far south as places like the US are. And so they have to launch, they launch from as far south as they can, but they've been experimenting with this idea of sending a ship down to the equator. And this isn't the first idea that this has been, this isn't the first time this idea has been tried. There was a company called Sea Launch that used to operate out of Los Angeles. And actually they would launch with Ukrainian rockets, and they would load up they had sort of they'd have a ship that would control the launch, and then they would have this platform that the rockets would launch from, and then they would tow the launcher down to the equator, and then they would raise the rocket and they would launch it from the equator, and then they would tow the launch platform back to Los Angeles. And they operated for a while, but then SpaceX kind of pushed a lot of people out of the market, and Sea Launch sort of shut down several years ago. And I guess the Chinese are experimenting. And I think, the rocket that is launched from their launch platform, there is a solid rocket booster, but it doesn't have to be. You can have a liquid fuel rocket, whatever. It's just that, it's just if you want to take advantage of it. But you have all of that hassle of getting your platform down to the equator. The other way that people have tried is you launch from an airplane. And we saw this with Virgin Orbit, where they had a 747 with able to carry an orbital rocket, and it would fly down to the equator, and then it would fly along. And then you get the advantage of the velocity of the airplane plus the velocity of the Earth as a way to decrease the amount of launch propellant that's required to get into orbit. But Virgin Orbit went out of business because still it's just the cheapest to go with SpaceX. Go with a reusable first stage rocket booster. It's tried and true. It's inexpensive. It's reliable. It's easy to get your payload to the launch site. It just seems to be the most successful launch platform until fully reusable 2-stage rockets come out like Starship. Zachary Wilson, wasn't Sea Launch stopped because of an ITAR violation? I don't know. That's interesting. I wonder. I don't really know the exact reason that Sea Launch went out of business. Bob Smith, do we think we are at the center of the universe like we used to think we were at the center of our solar system? Well, so the difference is that we used to think that the Earth was the center of the solar system, just because we didn't have the capability to detect the Earth's orbit around the sun using the parallax method. But with our understanding of the fact that we are at the center of the universe, it's because everybody is at the center of the universe. That, if the universe is infinite, then what does it mean to be at the center of the universe, right? Like the universe goes off in an infinite amount in all directions infinitely. But the other sort of definition that we use for the universe is the observable universe, that we are surrounded by a universe that we can observe, and that observable universe is custom to every one of us, that I am at the center of my observable universe, and you are at the center of your observable universe. And we are separated by some number of thousands of kilometers. And so when you think about the speed of light, I will see things that will then take a few microseconds for you to see, and you will see things that will take a few microseconds for me to see. And that's just because we have our own observable universe. And then the other thing is that the Big Bang didn't happen in any one spot. The Big Bang happened everywhere, that every part of the universe is trying to expand away from every other part of the universe. that no matter where you go in the universe, it will look like everything else is moving away from you in all directions faster and faster and faster. And so it feels like you're at the very center of that expansion. But the reality is, no matter where you go, you'll see roughly the same thing, which is that everything is moving away from you. Michael Brown, which constellation do I have to look through to see the Alice comet from Australia? I don't know where the comet is currently. I go out every night to see, I look to the west and I don't see it. Erwin, is Gaia still operational? It's operational. It's just they've ended the science mission and they're going to do some tests and then move it to a parking orbit. Scotty AU, is the Trump administration going to fast track the race to the moon and onto Mars? We don't know. We have no idea. Nobody has made any official proclamation for what is going to happen. On the one hand, Elon Musk has said that he thinks that there should be a lot of cuts to NASA, and he thinks that they should skip the moon and go straight to Mars. On the other hand, the Artemis mission was originally announced by Trump and is supported by Congress, and that there's a lot of people that are employed in the U.S. and there's a lot of momentum in getting them to go to the moon. And the NASA has already paid a lot of money to SpaceX to deliver a lander that's going to take people to the surface of the moon. And so there's a lot of inertia that's already built into this process. So I can't imagine things going faster. I can imagine there being some confusion. I can imagine things going, things getting canceled in the short term while people try to, come up with a new plan that maybe is more efficient. Almost anybody can imagine a more efficient way to accomplish some of these goals, right? That if Starship works as intended, well, then you just directly launch to the moon on Starship. You don't have to have the whole, why use the landing system if Starship can do the whole mission that you just, and even if it sort of feels too dangerous to put your astronauts on Starship while it's launching, you launch on a Crew Dragon, it meets up with the Starship, docks, they transfer to the Starship, and then they go to and from the surface of the moon, and then they fly back to Earth, and they meet up with their Crew Dragon again, and then you can have the Starship be the ferry back and forth from the Earth and the moon. And you can imagine other combinations, like maybe there's a way to retrofit an Orion capsule to be able to fit on top of a Falcon Heavy. Well, that would allow you to launch for $100 million instead of $4 billion, right? Or maybe you modify Crew Dragon to make a lunar Crew Dragon, something that is, has a bigger trunk, more capacity, more payload, that could launch on a Falcon Heavy and be launched to the moon. So there's a lot of options. But if you do any of that, then you're going to be stopping the current progress that has been built up over time. So that's going to be tricky, and all of these people who are working on this and have jobs and so on, right? So all of this, like there are a lot of possible ways that you can make the exploration of the moon and onto Mars more efficient if that is a priority. And if you throw money at the problem, you can make these things happen. But the trick is, how can you work with the constraints that exist, with the political groups who have, all of the stakeholders that are involved, all the stakeholders that are involved in this process. How do you work in such a way that satisfies them, that doesn't bloat up government spending, that makes sure to prioritize the safety of the people involved, that fulfills the existing contracts and commitments that have been made, that fulfills the international partnerships that have been made with countries like Canada. That there's a lot of moving parts. It is this Gordian knot. And so you can just cut the whole thing and just dispose of it and start from square one, but that has risks of its own as well. So I think, there's very few ways this can go right, and there are a lot of ways that this can go wrong. And it's about having someone who is leading NASA who will be able to thread that needle and be able to do that job. And so hopefully Jared Isaacman, when he comes in as the new NASA administrator, will be able to lead in a direction that that balances all of those factors simultaneously. But I can also imagine a lot of scenarios where it all goes off the rails, and it feels like we've been spinning our wheels for 4 years or longer. So we don't know what's going to happen. We'll just have to wait and find out. Cloud People Records, do you have the intent to create a launch base in Canada? There is one. There is a launcher in Canada being built right now in Nova Scotia. Boom. What'll happen if Blue Origin doesn't meet its deadline for the Mars mission? Probably a penalty payment, or have to launch it for free. Like, I'm sure there's in the contract, there's like a penalty if they fail to meet the window. Ivan M. Is the density of a black hole the same in the center of the black hole compared to the edges? So we can describe a black hole in two major numbers. We can describe the black hole in terms of its mass, and we can describe it in terms of its rotation, its spin. Now, you can also theoretically measure its charge, but anyway, it's mass and its spin. And from the mass, you can calculate the event horizon. This is the point where the escape velocity to get away from the black hole is the speed of light. And so as you get closer within the event horizon, then the escape velocity exceeds the speed of light. And if you are outside of the event horizon, then the escape velocity is a little bit less than the speed of light. And so light can escape. But we don't actually know what is inside the event horizon of the black hole. Mathematically, you can describe the black hole like the entire mass of the black hole. 10 times the mass of the sun, 1,000,000 times the mass of the sun, 1,000,000,000 times the mass of the sun. You can consider it in a single point, a singularity in space. And then you get, from that singularity, you get the event horizon forming as a size around that. But if you could actually look inside through the event horizon and understand what it is that you were looking at, what would you see? We don't know. So there's a range of possibilities. One possibility is that the black hole is just right underneath the surface, like whatever is, so think about it, go this way. So if you imagine, say, a neutron star is a ball of neutrons. It is the degenerate remnant left over when a star that is much more massive than the sun detonates as a supernova, collapses in its interior, and the protons and the electrons are smushed together to create these neutrons. And this gives you the neutron star. Neutron star is like the size of a city. They're like 10 kilometers across. Like, they're very small. And yet they have an enormous gravity. You would have to be going close to the speed of light to be able to escape from the surface of a neutron star. But if you are going the speed of light, you can get off, and that's why we can see them, because they can shine in radiation. And so imagine, right, you've got this spinning ball in space of neutrons from a neutron star, and you feed it material, and you feed it material, and you feed it, and it gains in mass, and it gains in mass, it becomes more massive, and then eventually you hit this, and at the same time, the escape velocity off the surface of the neutron star is going up. And eventually it will get to the point that the escape velocity meets the speed of light. And you now have a black hole. And so is what's inside, and so like an event horizon will form around this neutron star that is rapidly spinning. And so is what's inside the event horizon still is it still in there? But now you just can't see it because the event horizon, because it's, the mass has exceeded the speed of light. Maybe. But maybe the black hole collapses into, when it reaches that point, then maybe it continues to collapse. That in fact, the pressure that is holding the neutrons together is overwhelmed, and now maybe it turns into a ball of quarks, or maybe the quarks are overwhelmed and it turns into something even smaller. And maybe it actually does turn into a singularity, that the forces of physics can't withstand this amount of material that is crunched into a density that is this high. And so you can imagine it actually does compress down into an infinitesimally small thing. And so in fact, inside, there is the black hole that has all of the mass of the entire black hole that is down into this one single point. And then the rest of the interior of the event horizon is empty space. But it doesn't matter, because we'll never, we may never know. There may be no practical way that we can ever probe what is in the interior of the event horizon of a black hole. We might just have to be okay with that. Mouse Destruction asks, Stirling engines in space? Yes. Stirling engines work in space. All right, I'll answer this one. Mouse Destruction. Stirling engines in space? Yes. Stirling engines in space. So like a Stirling engine, and I don't 100% understand exactly how they work, but that when you have spacecraft that are attempting to use heat to produce electricity, like the radioisotope thermoelectric generators, they use this thermocouple to extract the heat from this decaying chunk of plutonium that then they can turn into electricity that the spacecraft can then use. Spacecraft can get a couple hundred watts out of this decaying chunk of plutonium. But another method that you can extract electricity from a system is to use this thing called a Stirling engine. And I don't know the exact operation, I apologize, but the Chinese have tested out a Stirling engine on board their space station and demonstrated that in zero gravity, the Stirling engine works. And so it could be a replacement for a radioisotopic thermoelectric generator. Instead, you have a decaying chunk of plutonium that is producing heat, and it's extracting heat through the Stirling engine to produce electricity. But there's also another idea that I really like, which is that on Venus, you could land a rover onto the surface of Venus and have its internal parts remain as cold as possible. And the outside of the rover is very, very hot. And then it uses this temperature difference between the outside of the rover and the inside of the rover as a Stirling engine to try to extend the length of the life of the rover while it's crawling around on the surface of Venus for potentially several months. There was a paper that came out a couple of years ago that I reported on where, yeah, they proposed that you could have a rover survive for a couple of months on the surface of Venus and not have its electronics fried by taking advantage of that difference. It came into the atmosphere of Venus incredibly cold, and it's still cold inside in this pressure vessel. And then you just slowly let the heat in, and you use that heat to generate electricity to move the rover around. So Stirling engines are an alternative to generating electricity when you have a heat differential. And like I said, the Chinese have tested one on their space station, and we reported on that a couple of years ago. All right. I'll grab one more quick question. Aaron Ball, do you know about the ISS replacement? Currently, there is no replacement for the International Space Station. There is a potential space station that's being built for the moon called the Lunar Gateway, which is expected to launch, in the late 2020s and into the 2030s. There are some private companies that are planning on building stations in low Earth orbit. Vast. There's a couple of others. And who knows if they're going to work out or if they're going to go out of business. We don't really know. And so right now, really, when the International Space Station is deorbited in 2030, the only game in town is going to be the Chinese space station. The only game in low Earth orbit will be the Chinese space station. Hopefully, someone will come up with a private station. My reporting experience over 25 years tells me that private companies that are attempting to do space tourism and things like that aren't very successful and have a high rate of going out of business. So I will be watching and reporting as various people are attempting to build private space stations, and I will also be reporting as many of them go out of business. So stay tuned for that. Yeah, Orbital Reef, there's a bunch of them. Bigelow went out of business. Was it the people building the spacesuit for the moon? They laid off like 100 people. So, like I think a lot of people think Orbital Reef, Vast, there are these companies that are planning on building space stations, but there's no guaranteed funding for these things. So my expectation is that they will all go out of business. All right. We're going to wrap things up. So thank you, everybody, for hanging out. I wanted to ask you this. Let me see. Are you in Asia? Now, when I say in Asia, I mean Australia, New Zealand, Asia, etc. Or are you not? Are you in North America? Are you in Europe? It'd be interesting to sort of see, did this work out for the people who are in the directed, the time zone that we were planning for or not? So let me know. A huge thank you to the moderators. I think Zap Van Zapfan was here for the whole thing. So, I literally could not do this without the help of the moderators. It would be rough. So no, that's interesting. That's funny. The Eastern Hemisphere. Yeah, a lot of the European one was a lot more targeted. Like a lot of the people in the Europe stream were in Europe. But it's interesting. People in Hawaii, Atlanta, Georgia, it's 3 a.m. Well, hey, I appreciate your staying up till 3. That's awesome. It's madness, but it's awesome. I'm not worthy. All right. Thanks, everybody. And we will see all of you this week because we're going to do a telescope live stream with the new planetary camera. So check that out. All right. Thanks, everybody. And we'll see you later.